want to find the curvature of RT when RT equals to t squared ln t ln t at the point 1, 0, 0. Well, after we write our equation, we want to find the derivative of RT, which will be equal to 2t, 1 over t, and 1 plus ln t. But of course, for us to find the curvature, we also need to find the second derivative of RT, which will be 2 negative 1 over t squared 1 over t. After we do that, we also want to find what are the derivative of RT, absolute value, which is, again, we have to find the square root of the coordinates given squared added together. So that'd be 2t squared over 1 over t squared plus 1 plus ln t squared. Now, as shown at the top where our coordinates, we're going to set to t is equal to 1. So then, once we do that, we should get 4 plus 1 plus 1, which will equal square root of 6. Once we have that, we're going to cross multiply, or we're going to find the cross product of r prime t, cross product of r double prime t. So then they should resemble like this, or should be this, I should say. I 2t 2j 1 over t and negative 1 over t squared. And for the k, 1 plus ln t over 1 over t. And when we cross multiply, we should get this long, nice equation. Well, I guess not equation, but variables to add. 1 over square root of t plus 1 over t squared times that by 1 plus ln t. And that's just for I. And then minus j, minus 2 times that by 1 plus ln t j plus, and this is where we're going to catch a little nice breather, which is 4 over t k. Now, since we now have that, whenever we simplify that where t is equal to 1, we simply get 2i minus 0j. When you plug in 1, you'll just get 0 minus 4j hat. And of course, whenever we find r prime, absolute value of r prime t, cross multiply the absolute value of r double prime t equals square root of 4 plus 0 plus 16. So we're taking these coordinates, plugging them in, squaring them, and then adding them. You should get square root of 20 when t equals 1. And then this is where we move on to the next step of finding the curvature k, not to be confused with the vector k. We get absolute prime of r prime t cross multiply by r double prime t over r prime t. And so then this would simply be square root of 20. May want to rewrite that to make it a little bit more clear. Square root of 20 minus square root of 6. And that is our final answer. Or if, for example, this isn't not to your liking, what you can do is times this by both by the square root of 6. So then this should equal to 6. Let me just verify. Square root of 6 times square root of 6. So then this should equal 6. Oh, or under, I guess. Feels kind of weird saying that when most of the time we're usually the top that we solve equals square root of 6 times square root of 20. That is also another acceptable answer. And that is our curvature. And if you want, you can go ahead and verify that, as I am doing in my calculator right now. And you should still get square root of 20 over square root of 6 is equal to approximately 1.83. And then square root of 6 times square root of 20 over 6 is likewise equal to approximately 183. So either way, either answer would work, and that is our final answer. Square root of 20 over square root of 6, or square root of 6 times square root of 20 over 6.